test. Advent of code and camel carts. Your unexpected trip turns out to be 5 minute ride in a shape that least it's a cool drops you off at the edge of a vast desert. You bring the carts around to see. You bring the she asks in go to this part she's looking for to figure out why this sand stopped. Parts for the sand is the rocks are all along the part of the desert island that is directly above island, making it hard to get there. Normally they use big machines to move the rocks and filter the sand, but the machines broken down because desert island recently stopped receiving the parts. They need to fix the machines. As you need to do a job to figure out why the parts stopped. She asks if you can help. You are automatically because the journey will take a few days. She offers to teach you the game of camel carts. Camel carts is sort of similar to so it's designed to be easier to play while riding camel. And camel carts you list of hands and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled one of 9 AQJ. The relative strength of each card follows this order, where is the highest is the lowest. Okay, in this order only. Every hand is exactly one type from the strongest to the weakest. They are 5 of a kind, where all of the 5 is the same level. 4 of a kind, one has a different level. Full house, where 3 cards have the same level and remaining. Okay, 3 of a kind. Full house, where 3 cards have the same level, remaining 2 are share a different level. share a different level. Okay, if a kind there were two cards share one level, or other cards share a second level, and the remaining card third level. And the two cards share one level, and the other three cards have a different pair. All are distinct. So there are some rules for this. Let's go to the question. Hands are primarily ordered based on type. For example, every house is stronger than any other kind. Its order is as followed as well. If two hands have the same type, second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with stronger first card is considered stronger. First card in each hand. And they will have the individual one type. For same types, we need to again do their consecutive comparing from left to right. First card, then second, different, then stronger cards. Consider lexicographical. Just consider this as the lexicographical order while comparing two hands of the same type. The hand with the highest second card is otherwise continue with the third card in each hand. Of a kind, but stronger because 3 should be before 2 in the sequence. Yes. So they are both a full house. Seven here 8 has more strength, right? So while comparing this third character, which are different, then the first one is stronger. To play camel cards, you are given a list of hands and their corresponding bits. And for example, this example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1. The weakest one. Because there are 5 hands in this example, the strongest hand will have rank 5 and it's to put the hands in order of the strength, sort these sequences based on these character sequences for each of them. Only pair and the other hands are all a stronger type, so it gets rank 1. Only pair, one pair or only pair? Yeah, one pair. Okay, so based on the rules mentioned above, we will simply sort them. Based on that, we will find out their ranks and determine the product of bid value multiplied by their rank. Fine. And the rank of every hand in your set. The total winnings. Let's go. 87. Don't need this. Given this sequence, and let's see the larger test case. Fine. Sample test case is this. Output for this is one would be 6440. Let's get it first. Vector of pair of string to integer. Okay, this is the input. Function put string and value. As long as we get them, read from the standard input and add it to our vector list. Done. Now we need to sort it. Only based on the first and only based on the string parts first, and then we'll multiply it, right? So that first we will get a auto second. In this, the first string to consider is, let's say, this, and it is first dot first. This should be pair of string to int. This is 1, this is 2. Dot first. If we check that first one is better than the second, then we return true. Simply check is better among them. You can simply do one dot first and one dot second instead of making copies of the initial strings. Now we need to write this better. Let's take these strings as constants. First as one. We have these many types. First we will find out the type of each of them. Type of one is get type for one, similar for And if type of 1 is better, let's say this is smaller is better, in that case type 1 is less than type 2, that means 1 is better, 1 is of better type. Then we want to say that you can keep you need to give this value a better rank. It's fine, we can simply reverse the list if it's not the case. Type 1 is type 2, then false. For now, let's say we return true if you want to keep 1 here, and this is of lower rank, and after this is of higher rank. And we can reverse the list afterwards. Else what we need to do is we need to check them. Both of these conditions are not met. We need to check them one after the other, character by character, and this is the order that we need to follow. This is card strength, right? Say we go over size of 1. Check the card strength for the first one. It's greater than card strength. Second, and true. C1. Less than C2. All since we continue. And if both of them are same, which should not be the case, yes, so it falls here. But let's see, and we need to return false because equal values should return false in a custom comparator function for C++. Let's write this function first. Card strength of some character ch. So here he has the highest, right? So vector arts to vector of, this could have been a string, but it's fine. And we go over all of them. Check whether this is the card that we are searching for. If that is the case, this has a higher rank, right? So we need to return a higher value here. It should be size of cards minus I. And we should never reach here because the character should be one of these cards. And next we are left with the type. Type string s. So we check whether all of them are equal. Let's do one thing. Let's find out their groupings as well. It's a vector of, we only care about the frequencies, right? So first kind has one unique element and it is repeated 5 times. The second has the frequencies 1 and 4. The third has frequencies 2 and 3. Frequencies means the number of occurrences of unique characters. Here it is 311. Here it is 221. And here it is 1112. Here it is 11111. Okay, fine. So we can simply it like this: map of character of frequencies, find out frequencies for all of them, frequency of that character plus plus. Then we need the frequencies individually. So say they are f, and this should store all the values in this map. Frequency f dot pushback v. Let's sort it to make it easier to compare. Then we check whether all of them are equal. That means the frequency is 5. Is comparison allowed? F is equals to 5. Okay, not allowed. So vector of int like this. Fine, this is allowed. If this is the case, that means it is of type 1. And since this is from strongest to weakest, there are 1, 2, 3, 4, 5, 6, 7 types. Let's say we return 7 from here. Then a case for each of them, right? Instead of that, let me something clever. If we have vector of int as types, the first one being 5, second one being 1 and 4, there are 7, right? 1 and 4, 2 and 3, I'm keeping them in the same order. 2, 3, 1, 1, 3, and I also need to keep them in sorted order so that comparison will make sense. 1, 1, 3, then 1, 1, 1, 2, 2, 1, 2, 2, 1, 1, 2. and in the end it is just all ones. Let me check it once again. So all fives, and 1 and 4, then 2 and 3, 1 4, then 1 1 3, then 1 2 2. Yes, this doesn't make sense. 1 1. This sums up to 4 only. So there should be 3 ones and 2. And after that, there is everything. And if we find the frequencies to be one of these, we send a higher value for a lower index. That's a type ID in size of types. If f is equals to that type, then we return, as I said, a larger value for a smaller index. It must be size of types minus type ID. And we should never reach here, so let's put an asset false here and return -1 just in case. Fine. After that, I wanted to see what is present in this vector, and I want to reverse it as well. First reverse it and then check, and answer would be size of rank is I+1 because this is 0 plus indexing, and e dot second. Of I dot second. See out answer. Let's see. Bracelet is wrong. Let's see. This is of the highest rank, so E55J5 K6 should be here. First of all, I need to check their types, I guess. The types 1, 2, it's fine. Check frequencies, push them in the vector, check to and return a to the found parts of I is equal to ch. Lower has a higher strength. It looks fine. Let's find out the type for all of them first, just for confirmation. Yes, and get type for this. See if we get the types first, correct. this is of type 2. I think I must have messed up the ranking of smaller values. 2 are both a pair, right? Yes, in this I'm returning from get type. I'm returning a smaller value. Or let's say smaller value is better. Then what we should do? Can type right here. Then smaller is better. Smaller is better than this should arrive earlier. This would be perfect as far as we want it. Or card strength as well. Do we need to do it for card strength? Don't think so, because we are essentially comparing them lexicographically respect to their strengths. Okay, looks like we get a correct answer now. And let's also check the final sequence. So 3 2 3 okay, is at the start. So rank 1. KJ is KT, JJT is rank 2, then KK66677, then E55, J5, and then okay, and this has a stronger first card, so this comes at the last means higher rank, and multiplication factor is more for that. Looks like looks fine to me. Segments and write on the actual test data. Let's check this answer. It's the right answer. Let's move on to part 2. Before that, let's copy our solution as a backup. To make things a little more interesting, the elf introduces one additional rule. Now, J cards are the jokers, wild cards that can act like whatever card. Make the hand the strongest type possible. Balance this, J cards are now the weakest individual cards. Let's also change this ASAP so that we are in align with the question. So they want sequence to be changed like this. The other card stays in the same order. The cards can pretend to be whatever card is best for the purpose of determining hand type. For example, this is now considered four of a kind. However, for the purpose of breaking ties between two hands of the same type, J is always treated as J and not the card it's pretending to be. So confusing. Treated as J and not the card it's pretending to be. For the purpose of breaking ties between two hands of the same type, J is always treated as J and make the cards tend to be. Okay, so we whenever we find out the type of a particular hand, so first we find out the types of these, right? And in that, if there is a J, then that J can be J cards can pretend to be whatever card is best for the purpose of determine. Now I'm unclear about whether all of the J's can be replaced with same card or they can be individually different ones. So they converted this to a 4 of a kind by making it, what do we say, 4-1. They made it a 4-1. So this was the best possible type conversion possible for this particular hand. Definitely, this is still the only pair because it doesn't contain any jokers and its strength doesn't increase. Where have they written about strength increasing? Don't think so. Still making it the second weakest hand. These all are now 4 of a kind. Yeah, right. Because 5 5 J and J can be converted to a 5, so a frequency vector would be 1 comma 4, which is 4 of a kind. Then similarly for this gets a rank 3, 4 and 5 because K should be the highest, right? No, A is the highest, but A is not there. Yes. In this input. Yeah. But while comparing them of the same type, we will simply keep the same function as it is. So basically, they just want us to write a separate logic for this function and keep the same logic for this function. With the new joker rule, the total meanings of this example is this. Using the new joker rule, we'll find the rank of every hand and what are that noted. Okay, fine, understood. To do that, what I can do is, first of all, we check whether a joker is not there. Then we apply the same logic. If frequency of J is greater than 0, we apply something else. Let's say apply return apply new logic. On S, else we do this. Okay. Now let's write this new logic. Get this. Let's also make it again. What I was thinking is try changing J to all possible other characters. So what am I doing? Let's say we are trying a particular character, let's say CH, to be replaced by J in cards, right? And it should not be equals to J because we want to replace it with something else. And let's create another string for which this replacement is performed. Character x in t, if x is j, x becomes ch, right? So after this replacement is done, we check the type. Now, now j is obviously not present in this, right? So we can simply get the type by returning by using the old logic. So to do that, I will again call this function get type for t, and this should not work because this function is calling this function and this is again calling this, so this is not allowed in C++. Let me write this something somewhere else. This old logic, we need the string, right? But then old logic will get some type. Let's say the type we got is old logic on this transformed string. It should not consist of j in this, so I can also assert that frequency of j is 0, and we need to find the maximum possible, right? To do that, best type for this should be, what were we doing earlier? We were saying that a smaller type is better. That's what we have considered, right, for comparison. So let's say it is something at the start, 10. Best type is minimum of best type, comma type. I can assert that it is not 10. There are no errors. Let's run this. Answer for this should be 5905. We have an assertion failure. If j is present, we apply new logic, else we apply the old logic. And in old logic, we find out the frequencies which that j is not present in them. We find out the frequency vectors, sort it and compare it with all the types that were given to us. And for new logic, we check that by replacing j with ch, this we achieve this string t. So I'm doing a reference. If it is j, then replacing it with ch and finding out the type for this using old logic. Where did it go wrong? Because I think we should check here that this should be sufficient. So if there is at least one j, we have a count of all s j is to 0. Let's check this. '67 line. This is wrong. There can be only one of these types, right? I don't think any other types are possible except these. Let's try to find out what it converted the original string into whenever it failed. Let's do an assert false, but before that, let's see what was the string here. Yes, and let's also see the frequencies. What else? Logic. Why is a 0 here? Yeah, I guess I know. So this should never. This basically inserts a key with value 0, a default value for any key in the map. So yeah, my bad. Frequency count g should be 0. That is what we need to check. Let me also check other references for this. So this is again bad, but it is fine because I'm not using that map again. Okay, so let's give true or false or integer. Count. Find the number of elements with given key. Okay, I hope that should be it. Let's run it now. The answer is 5905 as expected in part 2, but this was the first part's answer, so I forgot to remove it from the expected output file. Now let's run it on the main test. Quite slow, but works. That's it. Looks good. It was a good problem. I liked the problem. It was having a lot of details, and implementation could have been a lot of messier if we didn't consider using this. There would have been a lot of if else conditions otherwise. Yeah, I hope I can also reduce this. I think a lot of this is still repeated. Maybe I can refactor it sometimes later in some other stream. Anything else to? Fine, looks good. Let's copy sol.cpp to sol part 2.cpp. Let's clean up sol part 1 as well. This is fine, this is fine, let's end this. Okay. Remove in one sol.cpp test. Two new files to add. Git directory, add current directory, git commit day 7, git push. That's it. I'm closing the stream. Thank you for watching.